Wanted to talk about this Yamaha audio amplifier here. This is the Yamaha RX-V450. It's a surround sound system, video switch, FM radio as well, and it's faulty. Basically, it's plugged in right now, but if you press the power button, it won't turn on. It's a very common fault with this particular model, and it's a single capacitor there which failed. And I'm going to show how I diagnose this. The first thing you want to do is obviously take the cover off, and then get some freeze spray, because you're going to make the capacitor very cold, and try and figure out if that's the problem. So there is the capacitor. I'm just going to Okay, now I've done that freeze spray, power button, powers right up. And I've tested this and it does give perfect audio, and there's the speaker protection relay clicking in as well. Apart from this capacitor, the only other real problem that happens on these Yamahas is that fuse there for the switched outlet tends to blow, because people like to plug the things like plasma TVs into it. It's only rated for 100 watts. Other than that, these are very well built units, and that's a design flaw that only affects the 230 volt, 240 volt areas. 115 volt areas, not a problem. These things don't die, because that capacitor, the only reason it dies is due to main surges. The surges, tiny transients, damage the capacitor, but they have a nice self-healing mechanism. Older capacitors used to fail short circuit, but the polypropylene safety caps managed to heal up this damage, but at the penalty of reducing their capacitance. So after a certain number of surges, spikes, transients, whatever, the capacitor has reduced capacitance, and it's used as part of a mains dropper. It takes the 230 volts and drops it down to about 8 volts, 8 to 10 volts to run the logic chip there, which drives a MOSFET, which actually turns the standby power supply on and off to save power. Turns it on and off a couple times a second. It's quite a novel way of saving power. It's sort of a switching power supply, but not really. I don't know what you could really call that. It doesn't really switch at high enough frequency to call it a switching power supply. It also provides a signal. This 8 to 10 volts goes through a 6.8 volt Xena diode and an optocoupler, which sends a signal to this board or that board, which has the microprocessor on it, and that processor is looking for that AC power is okay signal, and that's why the unit appears completely dead. All the voltages will actually test okay. You'll get the 10.5 volts and the 4.8 volts. This unit, 10.5 volts, is generated from this board, sent across this board up to here, I think, and it's then regulated down to 4.8 volts and sent back here, where it then uses that and the logic signal back to there. So it's a bit over the place.